Hello everyone. In this lecture we are going to learn about subtraction of vector. If two vectors are given, then how to subtract that vector. Means subtraction of one vector from another one. Okay. So here in subtraction of vector, let assume vector A and vector B is acting at a point like this. This is vector A. This is vector B, and both are making here angle theta. So earlier lecture we have completed vector addition. Means when we will add here A and B, then we were getting a resultant, okay, going here in between A and B. So resultant formula means addition of two vector we have completed. Now subtraction of two vector. So subtraction of two vector means I want to find out this is vector R, which is nothing but A minus B, not A plus B, now A minus B. Okay. So A minus B. So we can also write this is vector A plus minus vector B. That means addition of two vector, vector A and minus B vector. So this one I will modify little bit. What will I do here? Vector A will remain vector A. This vector B will be in opposite direction. So we can write here this is minus vector B, and this was back initially it was this A was like this, this B was like this, making here angle theta. So this is just opposite minus vector B, and this angle will be 180 minus theta. Clear? So angle between A and B is theta. Angle between A and minus B is 180 minus theta. So now we have to add this vector A, this vector minus B. Okay. So here I will draw another diagram. Let me write here first magnitude of vector A. We will use here A. Of course, vector A mod is magnitude of vector A, and that I will write here by A only. So if there is magnitude, so simply I will write by A, and if there is vector, then I will write by vector A. Means A, and we will add here one arrow. So this will be a vector, and magnitude of this vector is this one. Vector B magnitude is B. Vector R magnitude is vector A minus vector B, and this is simply I will write here R. Okay. So here I will take here this is vector A. Now this is vector minus B. So what is magnitude of this vector B? Of course A, this is B, this is A. This angle is 180 minus theta. So resultant will definitely pass in between vector A and vector minus B. So this will be resultant. Okay. So this resultant will also make here some angle. This is, let's take alpha. Okay. So I will find out direction of this resultant. This is resultant R, which is A minus vector B. Okay. So means summation of vector A and minus B. Okay. So here we will find out resultant. So we know that magnitude of this vector R is, we know formula. If two vectors are added, magnitude of both vector is A and B, and angle between both vector is 180 minus theta. So I can use here formula A square plus B square plus 2AB cos 180 minus theta. Because now vector A and vector minus B, angle is 180 minus theta, and magnitude of this one is B, magnitude of this one is A. So I have to use here magnitude. This is magnitude A and B. This is angle between vector, and here angle between vector A and vector minus B is not theta, 180 minus theta. So we can write here A square plus B square plus this is 180 minus theta is minus cos theta. I will write here minus 2AB cos theta. So I am getting here this is R square, R square. So now I will write here A square plus B square minus 2AB cos theta. So there is little bit change in this formula. Earlier we were getting resultant of two vector A square plus B square plus 2AB cos theta if vector were added. Now vector is subtracted. So whenever you will subtract vector, then we have to change here in place of plus we have to put here minus sign. So this is resultant value. Now this is a vector quantity, so we have to find out direction also. Okay, so to find out direction, this is alpha. So here tan alpha, I will use same formula. Okay, so what was the earlier formula? B sin theta upon A plus B cos theta. Same formula we will use. B means magnitude of another vector. B into sin theta here, theta will be 180 minus theta upon A plus B cos theta. So here cos theta 180 minus theta. So I can write here this value is sin 180 minus theta is nothing but sin theta only. So this is sin theta upon this value will be A and cos 180 minus theta is cos 180 minus theta is minus cos theta. So okay, so here this will be minus cos theta. So I am getting here this alpha is tan inverse B sin theta upon A minus B cos theta. So this is direction I am getting. This direction alpha is of course from vector A towards minus vector B, not towards vector A. Earlier resultant I was getting here this is direction of R. So R was means alpha was from A towards vector B. Here this alpha will be angle between vector and vector A. Okay, or we can say alpha angle from vector A towards minus vector B. Okay, so from vector A towards minus vector B. Okay, so this is alpha. So this is angle alpha. We can say that this alpha is angle between vector R and vector A, or we can also say this much angle from vector A towards vector minus B, not towards vector B. Okay, so this is how we will find out resultant and direction of resultant. Okay, so based on it we will solve two questions. Okay, so here uh, example let's take here a particle is going in certain direction, suddenly change the direction. Okay, so here let's take a particle is moving in y direction and suddenly changes direction towards positive x-axis. Okay, positive x-axis. So particle is moving with let's take some speed like 10 meter per second. A particle is moving with 10 meter per second in y direction, suddenly changes direction towards positive x-axis. Find change in velocity. Find change in velocity of particle. So find change in velocity of particle. That means here we can understand direction of this one is, let's take here x-axis. This one is positive y-axis. Negative y. This is negative x. Okay. So particle was going initially along y direction. So here particle was going along this direction with what velocity? 10 meter per second. 10 meter per second. Suddenly changes direction towards positive x-axis. So this is final velocity. So magnitude is 10 meter per second. Magnitude is not changing, only direction. Suddenly change direction. So this will be final velocity, this will be initial velocity. So we have to find out change in velocity. So we know that change in velocity, that means final velocity minus initial velocity. So here vector subtraction is coming. Vector final minus vector initial. We have to subtract initial from final. Okay, so here we can write this one equal to, we can write here v final plus minus v initial. Okay, so here in this diagram I will draw here. In this diagram we have to add two vector. Okay, one v final. So of course v final in which direction? V final is in this direction. This is v final. Okay, and v initial was upside, but we have to take negative of v initial. That means this is v initial. So this is 10 meter per second again. This is 10 meter per second again. We have to find out real time. That means we have to add final plus minus initial. So this is final, and this is minus Vi. So we have to add both vector. Okay. So here, of course, both are equal, acting at 90 angle. So what would be resultant? Resultant will be this one. Resultant will be this one. Okay. So this resultant will be nothing but delta V, because this is delta V. This delta V is how much? 10. This is 90 degree. So resultant will be under root 10 square. 10 square plus 10 square. This is 10 root 2. So this is 10 root 2 meter per second change in velocity. We have to find out direction also. So this angle will be, let's take alpha. So alpha will be 10 inverse. Of course, both are equal. This is symmetric 90 degree. It will be 45 degree. But we can find out by formula also. So this is 10 upon 10. This is 1. This is 45 degree. So here, change in velocity is, we can say here, in between, means middle of x and minus y curve. Okay. So this is alpha, means from from x, positive x, from positive x towards minus y, 45 degree, means 45 degree from positive x towards y, positive x towards y. So this is angle, this is direction, and resultant I am getting here 10 root 2. Okay. So change in velocity you will calculate like this. Okay. So one more question, let's take. If I'm saying that a car is moving, okay, let's take here a direction, like I'm saying here, this is a north and this is south, this is east and this is west. Okay. So I'm saying that a car is moving in this direction initially. Car is moving in this direction initially. Let's take here speed 20 meter per second. Suddenly change direction and start moving in this direction. So we have to find out, this is 20 meter per second. Again, similar problem. Okay, so what is change in velocity of the car? Change in velocity of the car. So again, if I have to calculate change in velocity, so change in velocity means final minus initial. Again here I have to do final plus minus initial. Okay, so here two vector we have to add. Final that is in this direction. So here another diagram I'm drawing here. So final is downward. Final is downward. This is final. This is final. Okay. This is final downward minus Vi. So Vi is initial velocity this. So minus of this one is this one. So this one is Vi and negative of Vi. So of course both will be at 90 degree. Resultant will be this one. Resultant will be this one. So what will be resultant value? Again, they both are at 90 degree. So resultant will be 20 root 2. And what is alpha? Alpha is again here. This is alpha. So alpha will be again here 45 degree, because both are equal in magnitude. Clear? Okay, so this is how. One more question I will take here, question number 3. Okay, so this is question 2, question 1. So here one more question. Let's take a particle is moving in certain direction with v velocity. Okay, suddenly particle turns by theta angle. By theta angle means particle was going like this and particle turns direction by theta angle. Okay, so by theta angle means this is the initial direction and this is theta angle. So this one is initial velocity, this one is final velocity. So find change in that, change in velocity. Find change in find change in velocity. Okay, so initially particle was going like this, suddenly like this one, this is initial direction of velocity going like this, suddenly change its direction by theta. So find change in velocity. So how will I solve it? Here change in velocity delta v, that is equal to final, this is final vector. Let's take this is v2 vector. Let's take this is final vector, no issue. final vector, and this one is initial vector. Okay, so we have to calculate final vector minus initial vector. Okay, so here both vector is acting at theta angle. Okay, so here if I want to find out resultant, means this is something like subtraction vector, final minus initial, so this minus this. So when I'm doing here this minus final, this one is final vector, initial vector is this one, so I can write here initial vector subtract minus vi. That means here we have to add this Vf and plus minus Vi. So here we have to find out resultant. This resultant will be, this is V square. What is the formula? This formula. Okay, both vector here I have taken VV. So I can write here V square plus V square minus 2 into V into cos theta. This value will be this much. Now V square, this is 2 V square minus 2 V square cos theta. This value will be, you can take here common, root 2 V outside, inside 1 minus cos theta, and this is 1 minus cos theta. We can simplify this one. 1 minus cos theta we know, 1 minus 2 sin square theta by 2 we can write here in place of cos theta. So we can write here root 2 V, and this is inside 1 minus sin square theta, that will be plus 2 sin square theta upon 2. So this 1 cancel, I am getting 2, this root 2 it will make it 2v, and sin square will come out sin theta by. So this is very standard value, that's why I solve it better. You can remember this kind of problem, that if magnitude of both vector is same and subtracting one to another vector in such a way that angle between both vector is theta, so we can find out delta b, means subtraction of two vector which is acting at theta angle, so 2b sin theta by 2. Okay, so here one again I am repeating it. This was initial direction, this is final direction. This direction suddenly changes by theta. In general this theta can be anything. So initially it was moving like this, changes direction by theta. Here I have shown this is going direction, this is initially going, that changes direction by theta. So final velocity, initial velocity. Now how much is change in velocity? So change in velocity means final velocity minus initial velocity. So this is something like a two vector subtraction of vector. Okay, so this is b final plus minus bi. So this is, that means we are finding out resultant of this one and this one, and of course this resultant value will be along this one. So this is direction of delta v, this direction delta v, which resultant is 2v sin theta by 2. Okay, so here subtraction of vector, I'm applying formula, getting this much. So this resultant will pass through from vector v, means it will go like this. This angle also we can calculate. So this magnitude is important. Subtraction of two vector, if both vector is same magnitude, having angle between them is theta, so subtraction of vector is given by 2v sin theta upon 2. Okay, so similar problem when we were adding two vector of v and v magnitude acting at an angle theta. So I was getting there resultant equal to 2b cos theta upon 2. Okay, so there it was 2b cos theta upon 2, and subtraction vector is 2b sin theta upon 2. So better this kind of standard problem we should remember. Okay, otherwise it will take some time, we can solve it, but to save our time we can remember standard problem. Okay, thank you so much.